Hey Becca, what are we learning today?
Today we will be learning basic uses for Sohcahtoa. Sohcahtoa is an acronym that represents trigonometric ratios in a right triangle. So we have a right triangle here, has a right angle of 90 degrees, and we know that the side across from the right angle is known as the hypotenuse. That is h in the acronym. And then we have two angles that we're working with, angle A and angle B. S stands for sine. And if we're taking the sine of any angle in this triangle, let's start with angle A. O stands for opposite over adjacent. And that is referring to the side with respect to angle A. So the opposite side to angle A would be this one right over here, and the adjacent side to angle A would be this one here. C stands for cosine. Cosine is a trigonometric ratio for A that stands for adjacent over hypotenuse. So if you had lengths for all of these sides and we were looking for the cosine of angle A, it would be the adjacent length divided by the hypotenuse length. And the last trigonometric ratio in Sohcahtoa is T, which stands for tangent, tan for short. And if we're working with angle A again, opposite is O, and adjacent is A. So the tangent ratio for angle A is opposite over adjacent. Here's an example where there are defined lengths for each side of the right triangle. I'm going to go through and find all of the trigonometric ratios for angle A and also for angle B so we can notice the similarities. Let's start with angle A, and we'll start with S, which stands for sine. And we are doing opposite over hypotenuse. The side that's opposite A is 3, and the hypotenuse is 5. So in this triangle, the sine of angle A is 3 over 5. Let's try cosine of A. That's going to be adjacent over hypotenuse. The adjacent side to angle A is 4, and the hypotenuse is still 5. So we get 4 over 5. And our tangent of A is going to be opposite over adjacent. So the opposite side is 3, and the adjacent side is 4. So now we've got all three trig ratios for angle A. Let's try and do the same thing for angle B. Sine of B, opposite, 4, over hypotenuse, 5. So we get 4/5 for the sine of B. Cosine of B is adjacent, 3, over hypotenuse, 5. 3 over 5. And tangent of B is opposite, 4, over adjacent, 3, 4/3. So if you look at the trig ratios for A and B, some of them are similar. The sine of A is equal to the cosine of B, and the cosine of A is equal to the sine of B. Our tangents are not equal, but they are indeed reciprocals of each other. In this example, we have defined angles. So we know the value of this angle, and we have a right angle here. So we're looking at angles of size 45 degrees, and the side lengths are both 1. We're missing a side length. We need to figure out what the hypotenuse is, and we can do that by using the Pythagorean Theorem. A squared plus b squared equals h squared, or c squared. I'm calling the hypotenuse h here. Our first side length is 1. 1 squared plus 1 squared equals h squared. 1 squared is just 1. 1 squared is 1 equals h squared. 2 equals h squared. If we take the square root of both sides, we get h equals the square root of 2. So now we know what all three sides are, and we can find the trigonometric ratios for angle 45 degrees. So let's do the sine of 45 degrees. And sine is opposite over hypotenuse. So that's going to equal, we can take any of these angles to do these calculations because they're both 45, so I'm going to stick with this one here. Opposite is 1, hypotenuse, square root of 2. Now let's rationalize this so that we don't have a square root in the denominator by multiplying the top and the bottom by the square root of 2. And if we multiply the tops, we get the square root of 2. And if you multiply square root of 2 times square root of 2, the square root goes away and you're just left with 2. So sine of 45 degrees is square root of 2 over 2. Now let's try cosine of 45 degrees. This is going to be adjacent over hypotenuse. This is the ka in Sohcahtoa. Adjacent is 1. Hypotenuse is still square root of 2. And notice that this value is the same as the sine value, so when we rationalize it, it'll also equal the square root of 2 over 2. And that is the cosine of 45 degrees. Now let's do the last trig ratio. Tangent of 45 degrees is opposite over adjacent. If we're looking at this 45 degrees right here, opposite is 1, adjacent is 1, 1 over 1 equals 1. So the tangent of 45 degrees is simply 1. And all three values are very important because they are defined values for the angle 45 degrees. It will come in handy when you need to use the unit circle. The last example is going to cover another special triangle. This right triangle has 30 degrees as one angle, 60 degrees as another, and 90 degrees as the right angle. The relation of the sides of this special right triangle is 1 is the side length that's across from 30 degrees, 2 is the hypotenuse, and square root of 3 is the side length that's across from 60 degrees. And you can prove this by using the Pythagorean Theorem. We're going to find the trig ratios for both 30 degrees and 60 degrees. Let's start with 30 degrees. Sine of 30 equals opposite over hypotenuse. Opposite is 1, hypotenuse is 2, so for sine of 30 we get a half. Cosine of 30, adjacent over hypotenuse. Adjacent is square root of 3, hypotenuse is 2, and we get square root of 3 over 2. Tangent of 30 is going to be opposite 1 over adjacent. square root of 3. And if we rationalize this, we multiply the top and the bottom by square root of 3 to get rid of the square root. Top is square root of 3, bottom, the square roots cancel, and we get 3. So the tangent of 30 is root 3 over 3. Now let's do the trig ratios for 60 degrees. Sine of 60, opposite over hypotenuse, square root of 3 over 2. Cosine of 60 is going to be adjacent 1 over hypotenuse 2. And lastly, tangent of 60, opposite square root of 3 over adjacent 1. So square root of 3 over 1 is just square root of 3. Now these are the defined trig ratios for 30 degrees and 60 degrees. Also very important along with 45 degrees when using the unit circle. After watching this video, I hope you have a better understanding of how to use Sohcahtoa when using right triangles. If you have any questions, you can leave them in the comments. Give it a thumbs up if you liked it, and make sure you stay tuned because every Monday and Thursday we'll be posting new videos with new lessons, exciting math topics. See you then.